Sometimes I see these cool GPU-based robotics demos and I think, I wish my robot could do that. Like this one, where generative AI takes a low fidelity simulation and turns it into multiple photorealistic scenarios. Unless you've been living under a rock for the past 10 years, you probably know that you can use GPUs to really accelerate certain tasks in robotics. And since NVIDIA pretty much owns this space, you've probably heard words like Jetson, Isaac, CUDA, Omniverse, Cosmos. But if you're anything like me, after a few minutes of searching, you're left with your head spinning. There are so many different frameworks and examples and ways to start that it's all a bit too much. I think though that I've found the easiest way to dip your toe in the water, and I'm hoping you'll follow alongside me to see what kind of new and interesting functionality this will unlock. And as a bonus, at the end of the video, you'll get the opportunity to win a Jetson Orin Nano Super. Now this is a long video and it will feel like it jumps around a bit, so I recommend that you use the chapter markers to keep track of where you are. By the end of this tutorial, you'll be able to run GPU-accelerated robotics algorithms on either a Jetson or a normal x86 PC with an NVIDIA GPU, with sensor data coming from a log file, live sensors, or NVIDIA's Isaac simulator. I'll start with a quick overview of some of the terminology, and then we'll actually spend most of the time looking at NVIDIA's own tutorials and how you can use them most effectively. At some point, that involves some configuration that's specific to either the Jetson or a normal computer. You can just watch whichever one you need. And then the rest of the video will basically be the same for both platforms. We'll process some data from log files, from webcams, and then a quick look at Isaac Sim, although I've moved most of that content into a part 2. And then I'll finish up with a bunch of other tips and tricks and thoughts on where you can go from there. I'm going to be throwing around a lot of jargon in this video, so here's a quick glossary to get you started. GPU, Graphics Processing Unit, a particular chip design that's very fast for certain tasks. NVIDIA, one of the biggest companies in the world, designers of the first GPU. Jetson, NVIDIA's embedded GPU computing boards, great for robotics, vision systems, AI, and so on. You can watch my last video on that. CUDA, NVIDIA's software layer that lets you write general code to run on a GPU, not just rendering pretty graphics. Isaac, NVIDIA's CUDA accelerated robotics development platform. It's a catch-all term that includes classical algorithms, AI stuff, simulators, and more. Isaac ROS, a chunk of the Isaac stuff that builds on and links up with ROS, the de facto standard platform for robotics. Omniverse, NVIDIA's libraries for writing 3D graphics software that takes advantage of their advanced rendering and physical AI algorithms. So that's custom simulators, industrial tools, that sort of thing. Isaac Sim, a robotics simulator built on Omniverse that forms part of the Isaac platform. Cosmos, a bunch of generative AI models that NVIDIA has built specifically for replicating real-world environments and scenarios to accelerate the design of robots and autonomous vehicles. Whew. All right, take a breath and let's go. We'll be loosely working through the official NVIDIA Isaac ROS tutorials. Isaac is the name that NVIDIA gives to its whole robotics development platform. So that's everything from simulation to AI to classical algorithms. Isaac ROS is a set of packages and models that are designed to integrate neatly with the ROS ecosystem. Now, even if you don't know ROS or don't like it or don't want to use it, you just want to get straight into the raw CUDA, this is still a great set of tutorials to follow because they'll get you up and running very easily, and then you can kind of pick away at the bits you need later. And because we'll be doing it all in Docker, you don't even need to have ROS installed on your host or anything like that. And if you are using ROS, you'll be able to go ahead and make use of these components straight away. The official Isaac ROS docs are really detailed and helpful. Props to the developers for writing them, but if I'm being totally honest, they can be a little bit hard to follow. And so this is basically just going to be a tutorial on how to follow a tutorial, which shouldn't be necessary, but here we are. There are two main things you should know before you start these tutorials. First up is this table of contents on the left-hand side. So it's got all these headings and subheadings, and sometimes these correspond to subheadings on a page, and sometimes they're sub-pages within a page. So for instance, hardware setup is just kind of these links to the inside ones. Compute setup the x86 and Jetson platform headings are just subheadings within the compute setup page, but then all of these other sub ones within the Jetson platforms, these aren't subheadings within here. In fact, you can't see them at all. The only way to get to, for example, this preempt RT kernel page, you can get through by clicking next, but is really to go through this subheading. There are no kind of links or headings that are going to take you there within the content. If you ever get confused, just look back here on the left-hand side, see where you're up to, make sure you haven't skipped anything or gone backwards. The second thing to know is that a bunch of the steps fairly early on will refer to using a script that you're not told to download until much, much later. I think a lot of confusion would probably be saved if it just told you to clone that script right near the start. And you know, I might even submit a GitHub issue and maybe you'll come to this in 6 months' time and go, what's he talking about? It's right there. But for now, that's helpful to know. So with that out of the way, let's get started. So just skimming through these, we've got the system requirements. I'm going to go through them in more detail when we get to each platform. ROS support is designed to run with ROS2 Humble. And then we hit this first green box. And judging by the strong recommendation, you might want to click this link, but don't. It's going to jump you much further down than you want to be right now. The point of this box is really important though, so let me explain it in some more detail. Normally, getting a development environment set up to run Isaac ROS can be a bit tricky. It's not that hard, but there's a bunch of dependencies and configuration that you have to set up. To make this easier, NVIDIA supplies a Docker image, but recognizing that even Docker can be confusing, they have a script that takes care of all of that for you. So all you need to do is run their script and you'll have a terminal that's running inside their container. Getting files in and out of containers can be tricky too, so they get you to set up a directory on your host that gets mapped into the container. We call this directory the workspace, and we actually assign that path to an environment variable that gets shared across our terminals and used in all the tutorials. So you can dump files into there on the host, it will all be mapped across to the container, and you can use the same variable to refer to the path everywhere. If none of that made any sense, then don't worry, you'll pick it up as we go. But if you do want to know more about Docker, you can check out my tutorials on Docker for Robotics. But for now, let's move forward to the compute setup. We can see it's got two sections, one for x86 and one for Jetson. So here I'm on a fairly regular desktop PC with an i5 and an RTX 3060 running Ubuntu Mate 24.04, which is less supported than the older 22.04, but we'll make it work just fine. You need some RAM, an NVIDIA GPU obviously, and it says with the Ampere architecture, so that's at least a 30 series. I've got a 3060. Minimum 8 gig of VRAM and recommended 12 gig. I don't know what happens if you have less than that, but you can give it a go. I'm going to skip step 2, we'll come back to that. But step 3 is we need to have the latest NVIDIA driver installed. And it says minimum 560 required, and that's in order to get CUDA 12.6. So you can use the Ubuntu drivers tool. So if we go Ubuntu drivers list, we'll be able to see which drivers are available. Now on different computers, I had a bit of a different experience at different times. Sometimes 560 was available, some wasn't, and I had to add the PPA. If you don't have 560 available, you can do this tutorial on 550, just certain Isaac packages won't quite run correctly, but most of what we do will work just fine. So if I run NVIDIA SMI, we'll just make that a bit bigger, we can see I'm on driver 560, and that means it supports up to CUDA version 12.6. Now that doesn't mean I've got CUDA installed. If I go NVCC, you can see I don't have CUDA installed, but my driver supports CUDA up to that version. And we don't actually need to install the CUDA toolkit because we'll be running that inside the Docker containers. Speaking of Docker, back to step 2, let's install that. And we're just going to follow the official instructions to install Docker. And once that's finished, you want to jump down here and go to next steps, post-installation steps. And we're going to do these things that just make running Docker a bit more convenient. There we go, Docker's working. Now this is also a great time to install the NVIDIA Container Toolkit, We actually get told to install this later in the tutorial, but I think it's easiest to do it here. So again, we'll just follow the steps. And then you do want to make sure you scroll down to this section about configuration. So we'll run this step. And then it says to make sure you restart Docker. But I'm actually at this point going to restart the whole computer. That way all of the Docker changes and the toolkit changes will all take effect. If you're on a Jetson, then you want to follow these instructions. Now I have just freshly installed this from the official image from NVIDIA's website. And if you do that, most of these steps are already done for you. So install Jetpack, including the NVIDIA container package. That's done. You can run this, ignore that. Run this check command, and it says revision 4.3, which I assume is fine. It's above 4.0. Set the GPU and CPU clock to max. Okay. Set the power to max. So we'll run this command, which actually sets it to 15 watts, and this one can go up to 25. So I'm going to put it back to 25. Add your user to the Docker group. That's already done. If we go groups, Jetson, you can see Jetson's already in the Docker group. Set up Docker and add the Docker BuildX plugin. That's all also done for us. It then says consider adding more storage to your Jetson for a better experience. Developer environment set up for Jetson, which you might think goes to this developer environment page, but it actually goes to this Jetson setup page, which is the same as clicking next. Now this whole page is all about adding an SSD to your Jetson. It's got a couple of slots for NVMe drives, and it's highly recommended that you install one rather than running everything off the microSD card. This page actually describes two different approaches you can take. One is to install the whole operating system and everything on the SSD. The other is to still boot off the microSD, but just move Docker and a few other things onto the solid state drive. I've opted for the second option. It was just a bit easier to set up. So that's this option here, migrate Docker directory to SSD, and you can just follow those instructions. That's all I did, and that's working now. The next page here is about a real-time kernel. If you know you need this, you should follow these instructions. If you don't know if you need it, then you probably don't. So just skip that, go next. Finally, we've got Jetson set up for VPI. So I'll run these commands. And your output might be slightly different because I didn't have the screen recording when I did this a minute ago, the first time. And that should be all done. Everything else from now on pretty much is exactly the same whether you're on the Jetson or on an x86 installation. Once you've got your compute hardware set up, the next step is to set up your sensors. We're actually going to skip that one for now. If you know you need it, you can try and follow these, but they will rely on some steps that you aren't told to do until later, so watch out for that. Next up is developer environment setup. Some of these boxes are useful for read, so I do recommend that you go take a look at them. We've got the Docker configuration, so this is basically telling us on the Jetson to set it up with an SSD and on x86 to install the container toolkit that we've already done. Restart Docker, which we've already done. Now we can install git LFS if you haven't already got it installed. And then you want to run this command that sets up git LFS. Now we want to create a ROS2 workspace. This is really just an empty directory, and even if you don't have ROS installed on the host, that's fine because this directory is going to get mapped into our container. The only difference between these two options is what the path is. So just choose whichever one's relevant to you, or you can even change the path if you'd like to. And now once you've done this, every terminal you open is going to have this environment variable Isaac ROS WS that points to this directory. This box suggests you might want to customize your development environment further, but don't do that because it's going to rely, again, on steps that come later. But it's a good thing to come back to once you finish this video. Everything else in the Getting Started section we're going to skip for now. So that includes the Isaac app repository that kind of was invisible and didn't exist. But if you click on it, there is a page. The troubleshooting and the Isaac Sim setup and tutorials. We'll go into the Isaac Sim stuff in more detail later on. I'll quickly work through the rest of these headings over here. So the next one is the reference workflows. We won't go too deeply into these, but it's basically saying if you're interested in robot manipulators, then here are a bunch of packages, tutorials and stuff that work together for that application. And if you're interested in mobile robots, then their Perceptor stack is good for that. The concept section is definitely worth looking through, especially if you already know the problem you're trying to solve. If you're like, I want pose estimation, I want stereo depth, you can go straight in, have a look at how that works in Isaac. The one I will take a look at here is Nitros. You've probably not heard of that. So that stands for NVIDIA Isaac Transport for ROS. And that's basically an extra layer that runs on top of the normal ROS topics. That means that Isaac nodes can pass their data to each other via the GPU without having to kind of go back to ROS for everything. This will be used by the example workflows, tutorials, and so on. Then we get to repositories and packages. So each thing in this list corresponds to a repo within the Isaac ROS GitHub. And then within each repo, there'll be a bunch of packages. So we're going to start with AprilTag, which is convenient that it's first in the alphabet and also really good for getting started. As I mentioned in an earlier video, I'm keen to do a deep dive on AprilTags, but for now, we're just going to be following the steps. So there's a bit of an overview of how the system works. These green boxes are helpful, especially if you're already working with AprilTags on the existing ROS. It's about how to convert it to use the GPU. Then we've got a quick start here. I won't click that because we'll see it again in a second. A note about Nitros. And here's packages. So every one of these repos is going to have a section for all the packages. And the AprilTag repo only has the one package, which is Isaac ROS AprilTag. And we can see for each package, in this case, it's got quick start, examples, API, and so on. This quick start link is the same as this one. So we're going to click that. This is going to get us playing back a bag file and detecting AprilTags within that. And then it tells us how to connect a USB camera and finally how to use Isaac Sim. Now, don't skip the first one and try and jump straight into the later ones because there are some key setup steps we need to do first. And once we've done all that, that should give us a pretty good handle on Isaac ROS so we can go and take a look at some of these other repos and packages. So what have we got? Step 1. Set up your develop environment by following getting started. Done that. Step 2. Now this is the big one that I think they should put right at the very top, which is to clone Isaac ROS common. So this is going to have the script that we will use to run the Docker container. So you can see the first step in those commands was to cd into that workspace directory, wherever we'd put it, and then clone this script. Step 3, install sensor dependencies. As I said, we skipped that and we're actually going to come back to that later. Now we've got to download the quick start assets. Now every tutorial is going to have one of these blocks where it gets you to download all the assets for that tutorial. They're all ever so slightly different and it would probably be convenient if there was just a big one that downloaded all of them, but I suppose that would take a long time. I think you're meant to just copy and paste everything into your terminal, so we'll do this one, they're already installed. But rather than just pasting all that in the terminal, I prefer to make a script for it. And then I can execute the script. And then I'll just change the contents of that script each time we've got a new package. Now this is downloading the assets into our workspace, so that's on our host outside of the Docker environment. And then when we eventually run Docker, it'll be able to see all of these things we've downloaded and it'll persist across runs of the container. While that's downloading, let's have a look at this. So some more Jetson setup, we've already done that. And then finally, build Isaac ROS AprilTag. Now it's funny, it's got two sections. One is binary, one is build from source. We're going to use the binary, which is not actually building anything, we're just installing it. So has this finished downloading? Yep. So we can run this script and that's going to go and download the Isaac ROS Docker container. That was actually taking so long to download that I had to leave it alone and I've come back the next day. It looks like it's finished and it's started up a terminal inside the container now. And this image that it downloads actually doesn't come with any of the Isaac ROS packages by default, presumably in case you were wanting to install them from source. But we're not, we're going to run the binaries. So we just need to run apt update and then we'll install the ROS Humble Isaac ROS AprilTag package. The next thing it's going to get us to do is run the launch file, and the launch file is actually in the Isaac Ross examples package. So we need to make sure we install that one too. Once that's finished installing, we're going to run this launch file. Okay, so that's running the AprilTag Detection node kind of in the background now. We want to actually feed it some data and then see if it's working. So we'll open up a new terminal. And then what we can do, this is telling us to just run that run dev script again. And it'll detect if you've already got a container running with the Isaac Ross image in it, then it will attach to it, and it also prints out where the workspace is. So this is now a second terminal in this same container. And we can run this command to play a Ross bag file. You'll notice that it actually loops pretty quickly. The bag file only goes for a few seconds, presumably to save on download space. So it's not that interesting a file. It's just a few seconds looping, but it should be detecting April tags in that. So we're going to open a new tab and another terminal. And for most of these tutorials, it helps to have at least 3 terminals open. You're going to be doing this same pattern, one where you're running the node, one where you're playing a bag file or running a USB or whatever it is, and then one where you are visualizing it. So we can run this command to output the detections that it's got. So you can see there's some values here, but it's more interesting to view them ourselves. So we'll run rvis2. We'll add an image display. So there's the image. We can add TF. If we change our fixed frame to be the camera, then we can see it's got some frames that it's detecting for these 2 guys. And if we get rid of this image one and actually change it to a camera display, if we set the topic to that, you might have to click reset. It should. I forgot that the way they've set up this bag file, the camera info is actually on a different topic name. I'm just going to quickly remap it. Normally, you shouldn't have to do this. It's just that that bag file's been set up in a funny way. And now it looks kind of weird, but you're seeing these big blobs, and that's, I think, because it's visualizing these transforms from the point of view of the camera. And the timing, because it's looping this same little log over and over, they fade away. So you have to just keep hitting reset, but you can see it's correctly detecting those exactly where they should be. The next example is to use a USB webcam. So I'm going to go grab one. So I've got this webcam plugged into the computer now. And if I kill rvis and type ls/dev, you'll see that there's no video device inside the container. If I do it in the parent, there we go, video 0 and video 1. And we actually have to completely rerun the container script from scratch to rebuild the container with the webcam attached. If you were to follow my tutorial on using hardware with Docker, you could probably get around this issue. But I'm going to roll with it because it's a good opportunity to demonstrate something else we can do here. Because once we kill all these containers, when we rerun it, those things that we apt installed, so the April tag and the examples, are going to be gone. Instead, we want to find one of those links that goes to the Customize Your Dev Environment page. There's one here conveniently in the April tag section. This link comes up a few times within the documentation. So we'll click here and we'll see it's actually under Concepts Isaac Ross Dev Development Environment. So this talks a little bit about that run dev script. It's definitely worth reading through this. This talks about how you can change the way that it builds the image and so on. So what we're going to do is I'm going to open up a directory here in our workspace. I'm going to create a new folder called Docker, and then going to create a file called Dockerfile.mine because it's not a text file. So we'll just open with Pluma in my case. You can use whatever text editor you've got on your machine. And then we'll copy this content down here. So we'll go run apt-get update, apt-get install. And then the other one I'm going to add here is ROS Humble USB Cam. So that will install the ROS USB camera driver inside our image. So I'll save that. Now, if we follow these instructions, it says, if you write a file with the name .isaacross-config in your home directory, you can configure the environment. So I'm going to open a new tab. So this is in our host now. Go nano home / that file that I just pasted. So that's creating this hidden file inside our home directory. And then here are some examples of what you could include in it. But in our case, we just want to change the Dockerfile. So config image key, we'll make it that. Config docker search tiers. Now this is actually not quite correct. You want this to be home / workspaces if you've been following their instructions. So it's home / workspaces, Isaac Ross dev, and then I've put mine in a folder called Docker. There. So hopefully now, oh, I never actually killed that. Hopefully now, if we go to run that again, you can see it's looking in our custom folder and then hopefully has found that we want to do a custom Docker image. And now it's executing that custom Docker file that I made. So it's running the apt-get update. Then hopefully I've typed the names of all those packages correctly. All right, and so if I was to kill that and now run it again, it should be relatively quick. Not as quick as before we made our custom changes, but this way it won't have to do that update and installing those extra packages every time. There we go, we're in. And if we ls/dev, hopefully we've got our webcam available now. So if we go back to the USB camera tutorial, I've kind of moved a bit away from that. So step 1, complete the Isaac Ross AprilTag Quick Start, done that. Step 2, calibrate the camera following the instructions in the camera calibration tutorial. So this says, set up your development environment, print a large checkerboard, I'll show you that in a minute. Clone the USB cam package. So this is telling us to build it from source, but I installed the binary instead. Launch the Docker container, done. Build the workspace. That's only if you are compiling the USB camera driver from scratch. Then we want to run the USB cam image publisher. There we go. And then open another terminal. I'll just close that one, we don't need that anymore. So this is another terminal that's inside our container. And then we run the camera calibration node. Now in my case, I know that my size is 5 by 7 and the square is 0.030. So hopefully now, if you make this full screen, you'll get this black and white version of your camera feed. So I'm not quite sure what happened there, something that my camera driver didn't like. So now what it says to do is follow steps 6 to 8 from this camera calibration tutorial. So this is the official nav2 docs. So I'll just quickly follow them. We'll Control-C to quit the calibration program. If we go back here, if you just try to copy and paste this command, it's not going to work because it's got these extra bits and pieces in there. So we'll paste it anyway, but don't hit run just yet. So this is trying to CD into our workspace, and there's some extra bits and pieces here. So I'm actually going to get rid of all this because we're going to have to change this. And now we should have a file called camera info that's in our Isaac Ross dev workspace. So you can see here, camerainfo.yaml in there. And that way, because it's in that directory, we can have it persist between runs. So we'll go back to the AprilTag tutorial here. So calibrate the camera And then here it is for step 11, use Isaac Ross AprilTag instead of Isaac Ross package. So that's what it wanted us to do. However, you can see that that's trying to put it into the workspace / source / Isaac Ross meta package. And we won't have that source directory. Well, we've got the source directory, but we don't have the Isaac Ross AprilTag because we installed it from binaries. We didn't build it from source. So if you'd built it from source, you could follow these instructions. But because we installed it from binaries, our config file instead is in a completely different place. It's in /opt /ross /humble /share /Isaac Ross AprilTag /config. So there's the camera info.yaml that we need to overwrite. Now, because that is installed to the system inside the container, if we want to have that persist between runs, we'll have to run a command to do this copy inside our Dockerfile. But for now, I'm just going to do it temporarily. So we'll go sudo copy camera info.yaml. So that's the one inside our workspace. And I want to copy that over the top of the one that came with the AprilTag package. So now we should be able to, what are our next steps? Clone the USB cam package. Again, we don't need to do that because we've installed it from apt. Launch our container, yep. Build the workspace. We don't need to do that because we're not building from source. Finally, launch the provided launch file. All right, so that's started. And that should have run the USB cam driver as well as the AprilTag node, both of them at the same time. Oop, I've still got the old copy of the driver running here. Let's close that, close that. I'm just gonna clear this terminal and I'm gonna be running that one in this one. I like to keep that one running in the left-hand one. It just helps me remember which is which. So we're running that. And then in our second terminal, we want to run rviz. So now we need some AprilTags, which I actually don't have any printed out. So I'm going to bring one up here. All right, hopefully it can detect that. So if we move this over, you can see it's detecting it. As I move the tablet, you can see the transform moves around with it. Now, something funny is that despite the fact that we pass in the camera width and height here, that doesn't seem to pass it into the actual USB camera node. So I'm just going to install Nano. And then we can edit the USB cam parameters file. And we'll just put the parameters directly in here. So now when we run rviz, now we need to actually get something in there so that it has some transforms it knows about. So we can set the reference to the camera, add a camera object. Oh, we better actually add the transform visible. There we go. So now we can see the transform in the 3D view, but also in the camera view. So hopefully as we turn this, you can kind of subtly see the three-dimensional transform there. And then it says, if you're using a different camera driver package, ensure the camera stream publishes image and camera info topic pairs to the image and camera info respectively. Except I'm pretty sure it should actually be image raw. I'm not 100% certain, but that's what we're seeing in ours, unless it's doing some sort of remapping deep inside it. I can probably also show that one on there. All right, next up is AprilTag Detection with Isaac Sim. This video has already been going for quite a while, and NVIDIA has actually just changed some things with how Isaac Sim works in the last couple of weeks. So I'm going to break that off into a separate video. I'll show you some quick examples of it working now, but you'll have to look at part 2 to see how to set up Isaac Sim from scratch and get this going. Here I'm running Isaac Sim and the AprilTag Detection script on a PC with a 4080. You can see the centers are detected solidly, and even the rotation angle is pretty good. Isaac Sim will eat up all the GPU you can give it, and the first attempt at this screen recording completely failed because the hardware encoder only got about 1 frame per second. So this is with the CPU doing the recording. Before we wrap up, here's a few extra tips and tricks that might come in handy. Firstly, there's a great program called NVTop that tells you how much GPU processing and memory each process is using. Just sudo apt install NVTop and then run NVTop. Secondly, I had some strange issues on my PC where it kept thinking that the integrated Intel GPU was the primary and not wanting to do things on the dedicated one. After trying a few things, I ended up disabling the integrated GPU in the BIOS, but you might have to change some settings around IOMMU, which changes how the GPU gets passed into the system. Thirdly, something that can be useful is benchmarking. NVIDIA provides 2 repos around this. First is their version of ROS2 benchmark. If you stumble across it, you're probably in the wrong place. The other is Isaac ROS benchmark, which builds on top of ROS2 benchmark and has scripts to test all their various algorithms. It does have a quick start guide, which is great to get up and running with the AprilTag benchmark example. But for any of the others, the process to download the required assets seems pretty unclear, to me at least. I'll quickly flash some helpful notes up on the screen now for if you're trying to run these benchmarks for yourself. NVIDIA also provides some example results for the various platforms so you know what to expect. And here are my results for a few different benchmarks on the Jetson and the 2 desktops. At this point, you should have all the tools and knowledge you need to run any of these algorithms on log data, live sensors, or with a bit of extra effort, any ROS data source. And after the next video, you'll be able to complete the set with Isaac Sim. I hope this has you excited about what sort of things you can do with the GPU, and if you want to find out more, it's the perfect time. NVIDIA's GTC conference is on very soon, the 17th to 21st of March. This is where thousands of developers will be gathering to discuss the future of GPU programming and AI. You don't want to miss this opportunity to learn from global experts about how generative AI is shaping every industry, including robotics. There'll be talks on a variety of different topics. For example, there's a whole strand here on digital twins. And if you're like me and you can't get to San Jose, that's no problem. You can sign up for virtual access to the conference for free. Down in the description, you're going to find 2 links. One where you can sign up for GTC, virtual or in person, and one just for viewers of this channel where you can go into the draw to win a Jetson Orin Nano Super. That's about all from me. As always, you'll also find links on how you can support the channel and join our community, and I'll see you next time to learn more about Isaac Sim.